Good afternoon, everybody. My name is Justin Gehtland, and I am a villager with a hangover. So if there are other people in here who don't have hangovers, get out. This is the room for hangover people. I'm talking about Ruby, security and identity today. I'm going to give you a couple of brief notes before we get started. The first is, I'm really excited to be back at RubyConf for the second year in a row, especially given the fact this is the second year I'm at RubyConf talking about Rails. Don't boo me too loud. But I'm only going to be talking about Rails because I have to have some framework to actually implement a UI in. So we'll get to that in a few more minutes. Also, last year, my two experiences at RailsConf and RubyConf were that I was the talk directly after DHH at RailsConf and directly after at RubyConf. So I'm totally stoked to be talking after lunch this time. That makes me happy. Last note, we'll have about 12 slides, and then we're going to code until I talk, until I'm done talking. So without further ado, I am from Durham, North Carolina, so this is a short drive down for me. I actually grew up here in sunny Charlotte and was so desperate to get out of this hellhole when I was in high school. But now I'm back and I'm happy. So I'm the president of a company called Relevance up in Chapel Hill, and you can reach me at justin@thinkrelevance.com. That's an actual email address which you can actually use. Step one for security. Step one, Rails my app. I've written a Rails app, or a Ruby app, or a camping app, or something. Right? Step two for security. Script plugin, install, acts as authenticated. Right? For 90% of all the Rails apps that I've come across in my brief tenure, 2.5, 3 years professional Rails and Ruby development right now, that's it. There is no step three. Most Rails apps that I've come across authenticate all their users themselves against a locally stored database with, I have to say, cryptographically secured passwords, right? They have the salt, and they hash them, and the whole bit. So that's good. But since 90% of all Rails apps are coded this way, it turns out that Rails apps still suffer from a couple of problems in the world. So what we're going to do in this talk is talk about the ways that central authentication can be used and can solve problems for you. So when we start talking about central authentication, the problem with this I have my own app with my own data store, with my own usernames and my own passwords and all my own cryptography for dealing with them, is that first of all, I have redundant implementations. How many of you work in an environment where you only have one application? Anybody? 0 people, right? One guy, a noob. Get out. Most of us have to work in an environment where we have several applications ongoing at any given time. And if you are using, non-central authentication, you have redundant implementations. For most Rails shops, Rails-only shops, redundant in this case just means redundantly generated. Right? You just run acts as authenticated. You just install AAA, and you're done. So you assume that it's well-tested, and you assume that between different installs of AAA, you're not getting radically different code. But it's still redundant implementations, and as we all know, the prime developer rule in the world today is the dry principle of not repeating yourself. That means not only not repeating yourself in stuff that you write, but stuff that you install. Right? So that's one problem. Second problem is no shared authentication. Right? If you've got 3 applications, each of which are authenticating users singly, then users of all 3 applications have a bad user experience. Every time they move from one app to the next, they have to enter their username and password again. This can be onerous or not onerous, depending on how good or lame your users are. If all your users have the same username and stupid 4-letter password for every application they visit, then woe betide to them. But the user experience isn't nearly as bad as for those people who actually maintain a good password and a different one for every application. And now they've got to remember, I got 3 apps at this company, each of which is a different password, and that's a pain in the butt. And frankly, the third problem is commingled storage. You don't necessarily want to have cryptographically secured user data, palling around in your blog application. Right? I got a bunch of blog data that's publicly accessible. Do I really want to keep my usernames and all of their account information sitting around in that database? Sometimes yes, but sometimes no. Right? So what you'd really want is a shared or central authentication environment to give your applications a better way to deal with the user ID. Now, we'll come back and talk about this stupid UML diagram in a minute, but there are two types of central authentication in the world. There's private and there's public. A private central authentication system is one that works within some sort of boundary, within a firewall, on a LAN, on a WAN, within a corporate environment. These are the kinds of single sign-on environments that work across multiple enterprise applications, pardon the use of the E word. When you have your HR application and your payroll application and your time off application and whatever else is going on inside the corporate firewall for the users to access, you want to provide a seamless experience such that your users can log in once, move from app to app, and not have to keep logging in over and over again. And you want a central place to store all of that data, the really, really, really important to keep private data, especially depending if you're like a financial application or a medical application, right? You've got to really be sure about that stuff. So you want something that gives you high fidelity, high robustness, good security, and you don't want it accessible to the outside world. So you have a private single sign-on authentication system. Historically speaking, that problem has been solved by commercial vendors like RSA. Anybody ever dealt with RSA? Anybody here work for RSA? All right, good. So when I would say the next thing, nobody will hit me. RSA Clear Trust is an example of a single sign-on, a commercial single sign-on. Anybody ever worked with that application? Anybody know how much that cost your company to buy? So probably like $2 million is a good round guess. Right? It's negotiated with every vendor. All right, so $2 million to go and get somebody to install something that sits on top of a database of usernames and passwords and allows a bunch of applications to utilize it. For $2 million, how much code do you get? 5, 10 lines. I mean, it's not much, right? Couple hundred K probably. Some sensors to drop around. What do you get for $2 million? Somebody to sue for $2 million. Yeah, you get a EULA that nobody reads and somebody to sue when it all goes down the tubes. That's what $2 million buys you. They're not shy about telling you that. They have to charge you $2 million to build up the legal defense fund. Right? Single sign-on stuff is actually not terribly difficult to implement once the standards are well known. It's just that if you go and implement something that's open source, like I'm going to show you how to do, there's nobody to sue. I don't think that should hold you back. And I hope that after this talk, lots of you will run back to your companies and say, hey, this open source SSO stuff is really cool and we should think about it. Can we sue you for telling us about it? You cannot sue me. You signed a EULA by walking in the door today. A little snapshot of everybody on my laptop. The other type of central authentication is public, which means something that's available on the great wide World Wide Web, the interwebs, the tubes, the trucks, right, whatever they are. Something that you can go to an application that you've never seen before, you're not behind a firewall, it's available to you over to an open HTTP port, but still supply an ID that identifies you across lots of different applications. Right? Anybody here use an OpenID identity? Wow! Anybody here never seen OpenID before in your life? Wow, that's incredible. Go Ruby crowd. So OpenID is a good example of this. This is a solution that allows you to create multiple personas that are centrally stored somewhere on an open server. Those personas are uniquely identified by the one true unique identifier we all know and love, a URL. So you get an identity that can be tracked via something that's unique to you, a URL that only you can have. And you can supply that URL to random applications who can then go off to that central server and verify that you are who you say you are. There's a huge difference between the private version of central identity and the public version of central identity. Does anybody know what the big difference is? What's that? Federated. More low level than that. Trust. Inside of a private single sign-on environment, you not only know that this person accessing these 3 applications is the same person, but you also know exactly who that person is. In a public central identity server, pretty much you just know that this person is the same person across these 3 apps. There's no way of verifying that they are who they claim to be. For example, I could easily go off to my OpenID and create evilrussianhackers.org.myopenid.com. Then I could go and sign on and to 6 or 7 different web applications, Campfire and Basecamp and 3 different comment systems on 4 different blogs and whatever else, and use that URL. You can, if you see comments by that URL across 4 different blogs, you have a way of knowing that it really was me jumping around and leaving all those comments. But you have no way of knowing if I am who I claim to be. There's no way to track that piece back. But in a private SSO, you dang well better sure be able to track that piece of information back, or else the whole system's pretty useless. So we have private and public central authentication. In private, there's a circumscribed set of apps that are allowed to take part. In public, apps opt in to the system. So with OpenID, applications who want to allow people to use their OpenID can just install the OpenID stuff and opt into it. They're not mandated to do it. It's usually a benefit to the users, a service to the users to have done it. Okay. So we're going to talk about OpenID. We're going to go through and actually build some applications using both of these things. But what I'm going to use in the demo is my OpenID, because that's the account I have. Yeah, question here.
There's an intermediate step. It's not possible for a private to use OpenID for private authentication by restricting the OpenID URLs, basically.
Yeah, you can do all kinds of funky things about allowing URLs of a certain that match a certain regex or that have a domain or something like that.
I want to give OpenIDs to my employees. I'm going to verify that they're authenticating against my server, but on the other, for my application,
right.
On the other hand, they can use that as OpenIDs.
Absolutely, and by the way, OpenID is its own implementation spec. You can install and create your own private OpenID servers, which lots of people have done.
There is a real-world example of what you're talking about, and that is Sun.
Yeah.
That to their
So the question that was up here was, couldn't you use OpenID for private single sign-on, but also let people then reuse those IDs out in the world? And yes, that's possible. You create your own server, you just install the software, create a domain, install it, let people create their IDs there, and you can circumscribe and say, look, you can only access these apps if your OpenID comes from this domain and it's been authenticated there. But if you're talking about the ones that are available by going to myopenid.com, there's not much you can do because you have to trust them to do the verification. All right. So OpenID, vendor supported but not vendor controlled. Again, there's lots of big name vendors who are out there supporting the OpenID standard, but none of them actually controls the implementation spec. And since it's open source, you can download them and install them yourself. On the Ruby side, when you want to interact with OpenID, the easiest way to do it is using the Ruby OpenID gem, which is actually a combination of 3 different important pieces: Ruby OpenID, Ruby Yatis, and if you're interested in doing Rails, then the Restful Authentication with OpenID plugin, which is what I'll show you in action in just a few minutes. And Yatis is a gem that combines OpenID transports and API calls with a directory service, so you can find OpenID servers. Now, in practice, most people don't use directory services. This is the same with this as it was with SOAP and web services in general and UDDI and all those other things. It's a great idea, but very few people ever sit down at an application and say, I would like to authenticate via some OpenID server. Now let me look at a directory full of potential OpenID servers to do it with. Right? That's unusual at best. But it is available to you through the Yatis gem if you want. On the private side, we're going to talk about, I'll come back to that in a second. On the private side, we're going to talk about CAS. Anybody here ever seen or used CAS? Yale's Central Authentication Service. Anybody never heard of this in your life? See, that's just so sad. CAS is open source entirely, was written at Yale University for providing single sign-on across their academy, all the academic units. But then they released it, and it got sort of subsumed into the JSIG project. Now, it's a web app, and it's written in Java, and it's a war. But it's also an open spec as well. And recently, there was released the Ruby CAS server. Anybody seen this? So the Ruby CAS server is a web application that you install and run, but it's all written in Ruby, and it does exactly what the Java version would have done, except you don't need Tomcat or Jetty. You just run it anywhere you want.
CAS is just authentication, not
authorization.
Authorization. Okay. And just out of curiosity, are you going to discuss the fact that you could use a public authentication system and say, okay, I don't trust anybody, and then add trust on top of that, even to private systems? Okay.
Yeah, we'll talk a little bit about that. So with CAS, that thing Java-based there, but again, there is now a Ruby CAS server, which is what we're going to use in the demo. Now, I have a book to give away, High Performance Websites, Essential Knowledge for Front-End Engineers by Steve Souters. I've been told to give a book away, and to give a book away, I have to ask a question. So I'm going to ask this question. Anybody have a guess as to what Ruby CAS server is written in? Raise your hand. Not, and I don't mean Ruby.
C.
What?
C.
No, it's written in Ruby, but on top of that.
Camping.
Yeah, oh, okay. Who shouted camping out first back there? Have a book. So I know that Nathaniel gave a talk in which he said, flippantly and probably not seriously, with camping, and it's not just for toy applications. You might actually use it for something real someday. This is a great example of it being used for something real, and I'll show you the code in a couple minutes. So the Ruby CAS server is, in fact, written in camping. All right. There we go. And what we're going to use on the Rails side, again, for dealing with CAS, is the Ruby CAS client, which is a plugin you can install for your applications that deals with going back and forth to CAS. So let's go back and talk. Oh, and I have to say, why am I suddenly humming? I don't know. So with central authentication or authentication of any kind, many applications stop with a database. We create a database with a table called users. It's got two fields, usernames and encrypted password, and then we just deal with that. But if you're working in the large e-enterprise scenario, you probably have to deal with something else. LDAP, NTLM, some sort of commercially provided authentication service, something like that, that you have to be able to access. The good news is that Ruby has bindings to all these things. Anybody ever used Active LDAP or RLDAP or any of those systems, right? So Ruby can bind to LDAP. Ruby can bind to the NTLM systems, the Windows subsystems, and all that stuff. And what's great about, for instance, the CAS server, which is open source and free, is that it has a plugin architecture called the Authenticator model. And basically, it's got 3 or 4 built in. You can choose one of the standard ones, and if you don't like them, you can author your own. But the standard ones always include LDAP, and usually include NTLM and whatever else, right? If you're doing the Java one, it's got like 50 authenticators you can use out of the box. If you're using the Ruby one, there's 4, and then you can write your own. It's a very simple set of code to write. So let's go all the way back to my UML diagram for a moment, which is hard to read, I know, but let's talk about what all of these systems are going to have in common. You're going to have a user who attempts to access some locked portion of an application, a page that they need to authenticate themselves with before they can access the data they're in, right? The application is going to notice that there is no authenticated session with this user and take an action. That action is to send a client-side redirect over to the authentication service. Right? So they request the lock page, they get a client-side redirect, the browser goes off to the authentication store. The browser says, hey, that page that it's getting is going to be a form. In that form, they type in their username and their password, and they hit submit. That central authentication service is now in charge of taking those credentials, looking them up in the data store, authenticating them against that table, and creating some sort of piece of data that they can attach to the next request that allows a subsequent application to identify this person. So the central authentication store takes the credentials, looks them up, oh, I know who you are, and creates a piece of data. Just keep that in mind. We're not going to talk about the piece of data just yet. Creates a piece of data, sends back another client-side redirect back to the originally requested page with that piece of data attached to it. Now the browser goes back to the original page, hands into the service. The service says, I still don't know who you are, but you have this piece of data that I can look at. Your application takes the piece of data, sends it all the way back to the authentication store behind the scenes, and the authentication store says, oh yeah, that's a token that I gave out. Here's that person's username. You're off to the races. And now your application is free to create a session and never ask this user again. That's central authentication. What's interesting about central authentication in this part is when the second application that's part of this federated environment goes and asks, right? Now you go across to your app number 2, send a request. I don't know who you are. Now you get forwarded on to the original authentication store. But guess what you have with that authentication store? A session. The authentication store already knows who you are, can attach another token without asking for your credentials, and invisibly you end up back at the page you asked for, but you're logged in. That's the beauty of that system. And we're going to do all this in code right now. But just to show you what pieces of data get thrown around, here's what happens when you're using OpenID in a Rails application. If you get redirected over, you'll see that, you'll hit the page. This is the redirect that your browser will get back. Oh, go to myopenid.com, right? And you want to be in check ID and setup mode. You're going to return to localhost 3000, account complete. That's the action you're going to hit. Then there's a token that's attached. There's parameters required for OpenID to send back. In this case, I want back username and email address. Those are pieces of data you can pluck out of a persona at OpenID, right? And then at the very bottom, you can see that, oh, there's my OpenID that I provided, jgetland.myopenid.com. And then there's an SHA-1 sort of token. What you get back, once Rails has parsed it all out, is a whole bunch of interesting data. Oh, it was returned to localhost 3000 account, complete, with a nonce. Right? There's a signature, there's the original endpoint, here's the response nonce, there's the email address associated with the persona that they used, justin@thinkrelevance.com, his original OpenID, right? All that fun stuff. This is the part of writing a single sign-on service that's not easy. You had a question? Yeah. A nonce is salt. It's a piece of arbitrarily used one-time data to make the hash be slightly different than it would have otherwise been.
One of the objections that I've heard to OpenID is this idea that you can have an attack, you can have an evil web server. Basically, rather than redirecting to the OpenID server that the user gave you, redirects to some evil OpenID server, which then gets his password.
Yeah. So. Yeah. The problem. The question he said was there's a potential attack in OpenID, which is that a web server essentially impersonates an actual OpenID server, takes credentials and returns tokens. And the answer there is yeah. There's what's that?
But if you use TLS, that won't work, right?
If you're using all SSL, you can at least verify the certificates. Yeah, as Tim was saying, if you use TLS, you get a way to at least you have to then actually look at the certificates and make sure that's now up to the user. But, yeah. So but this is the web of trust problem. When you have a publicly available identity server system, you got to trust people along the way, and there's only so far the technology can take you.
It's hard to escape detection because one, if you don't look like the login he's expecting, he's going to know it right away.
Right.
Two, if you come in and it's the first time and he goes to his next OpenID app and doesn't have a session, that's another.
Right.
So yeah, wouldn't you have to intercept two transactions though? First of all, the original OpenID request to the OpenID server, but then the token that's returned is given back to the application. The application then goes and requeries the OpenID server, so you have to intercept that as well.
You'd have to have replaced the routing to the actual. You'd have to get both ends of it. Yes, you couldn't just intercept one half of it.
Well, unless it's an evil. Basically, the evil website could actually do this itself. Right?
Yeah.
It's not that you're not trying to say the website. The website's basically trying to.
Yeah, a website could pretend to be using OpenID, and that's what a user can't stop.
There's just as a possible option, some banks do things called site keys.
Yeah.
So that you picked that when you first signed up at your original one, and it's only something that you know, and it shows that and says, if this is not your site key, don't put in your username and password. And I think that might be one option. And it can be done at the OpenID, at the host that's providing the OpenID. So.
But I think his point was that from a user perspective, if I'm going to an application that I think is using OpenID, I can't know that it is. Yeah, he might send you to any website he wants because he's right. So you're actually using an evil application, not that OpenID has been subverted in some way.
But the redirect takes you to your OpenID server, the one you give it. So
What I'm talking about is a phishing site that is spoofing that it's using OpenID, right?
Right. You'd see that because you would just you'd have to be looking at the browser bar. right? There are ways, there are problems there. So without further ado, let's go and implement this so we can actually see it in action. We can play with the data all we want at that point. So I'm going to create an application real quick from scratch, right? I got nothing in here. So we're going to create an OpenID application, and then we're going to create some CAS stuff. So I'm going to create something that allows me to manage some notes. That's the easy part. So, right, some very scripts, generate scaffold, evil scaffold. Name is a string, and body is a string. All right, so now I have an application that will let me manage notes, just the way that a good old scaffolded Rails application will always do. Now I'm going to install a plugin. And this is the Restful OpenID authentication plugin. Thank goodness I have my own EVDO card. Wouldn't want to be using the shared wireless in here trying to do this. That's going to install, la-di-da-di-da. Almost there. Getting closer. Stay on target. Red number 5, I'm going down. All right. Now I'm going to generate my OpenID authenticated. Oh, yep, sorry. Is that better? Authenticated user and account. Right. User is the model, account is the controller. Now I'm set, I'm good to go. We're going to modify our application a little bit. Unfortunately, there is one problem with the way that this, I'm using Rails 2 now, the pre-release, and there's actually a problem with the way the OpenID authenticated plays with that, which is I have to go in and change the names of these controllers that got generated, accounts. And it's kind of a pain in the butt, but just bear with me for a second. And then I got to change this folder name. And then I got to change something down in here. There we go. All right. So I've got my account controller. This is the controller that got generated and installed that does all the OpenID stuff for you. And we're going to see how we use this in a second. First, I go to public, take out index.html. I go to routes.rb, and I map root, controller notes, and good old, this guy actually gives me stuff I paste in to map my new controllers. All right. Now, ladies and gentlemen, that's pretty much it. I can't really do a demo unless I actually have some output that's going to show you that you're logged in or not, though. So I got to go modify something like, for example, the layout. Anybody here sit through the refactotum talk? Ms. Stewart. I'm about to give you, everybody in this room, something you could go and refactotum. All right? So in my layout, I want to put out a piece of text that says hello to whoever the user is if they're logged in. So it turns out that the plugin here uses the current user, right? Uses current user, and I got to jack that up there, to store the actual logged in user in the session. But current user, if you fail to log in, the OpenID plugin that currently ships sets current user to false. But it actually sets it to the symbol false. Which means if you do this, the answer is always true, even when it's false. Because the symbol false doesn't equate to false, which is unfortunate. So if anybody wants to go and fix that,
it's called log in with the question mark.
Yeah.
It actually does a comparison.
yeah, so you can use the new logged in one. Yeah, it's probably in this code base actually, but we'll do this for a second, and I'm just going to spit out hello current user login. Oops. If you're logged in, I'm also going to provide a link to the login, just so we can all be happy. And in login, in this case, the controller is accounts, and the action is new. All right? So let's do it. I've already created the database, so what did I get wrong? Hello, quote. All right. So, Firefox. Right. Hold on. Good old live demos. Put in application. Start. We'll get there. There we go. So, I have an application. Yay! And there was much rejoicing. Scaffolding. So, as you can see, I'm able to use the application all I want without having logged in, because in this particular case, identity is merely an optional part of the site. The scenario I'm showing you is the kind of scenario you would give if you had a blog and you wanted people to be able to use their OpenID to attach an ID to their comments. They don't have to provide it to you. If they don't provide you their OpenID, you'll probably tag them as anonymous coward, right? But if I do want to log in, I can either provide my OpenID URL, or I can provide a username and password. It turns out when you use this particular plugin, it'll provide you both versions. In my case, I want to use my login. Now this takes a minute because I'm on EVDO and this site is slow and you have to deal with it. Yeah?
This is a good question, Marvel, for this thing. Should you even offer the login password if you're going to go for OpenID?
Yes, you should if you have two kinds of identity that you're tracking. If you're mixing public and private, for example. Again, because if you're using a public OpenID server, you don't want to let admins log in through that necessarily, right? You have your admins log in through a provided username and password. You don't have to. You can certainly do it either way.
Simon Wilson talks about it. It basically serves as a forgotten. If your OpenID server is down,
right.
It's nice to provide the user an alternate way to get in.
Yeah, that's an interesting point. I hadn't thought about that. That's a robustness feature as well, because you're depending on an external service. Now, the chances of OpenID server actually being down for any length of time is probably small, but still. Hold on a second. Let's just get through it. I'm going to type in my password. I'm going to tell it, no, I don't want it to, right? So I'm on the OpenID sign-in. You can see I'm on myopenid.com. And now I get to choose my persona. This is the cool thing about OpenID. You can have multiple personas. I have the default persona, and I have my Justin Gehtland persona. And then I can say, oh, allow once, allow forever, or deny. Because at this point, you are on a page that says, look, hey, user, a site identifying as localhost 3000 has asked for you to confirm this login. Do you want to allow it this one time? Do you want to allow it forever, in which case a permanent record is put in there? Or you can deny it. If you deny it, you can be logged in. Yeah.
If you look in the upper right-hand corner of the OpenID site, it's got your personal icon.
Yeah.
You can upload some image, and that's actually tied to your browser on that system. So that's one way to kind of protect against the phishing.
And I always have to remind myself doing demos like this to click allow once. I don't want to bind localhost 3000 forever. Now notice I got redirected back to localhost 3000 and bang. Right? Oh, I successfully verified and hello Jay Gehtland. And not only that, but if I go and I look in the database, right, so here is my notes database down here. I have a users table. You'll see that, in fact, a record was created with my email address and my username, right? No crypted password, none of that stuff. Right? But all that stuff is tracked for me, and then that last one is the OpenID. I think column is busted in the view, but that's my OpenID URL. Right, so now my application knows about that user, and you can use information like his login name, Jay Gehtland, or his OpenID as part of your authorization scheme. I haven't mentioned this yet, but none of this stuff is authorization. Right? This is all authentication. You never, ever, under any circumstance, fob authorization rules off to a central service. Because authorization is almost, and I don't want to stress this too hard, but I'll stress it as hard as I can, almost universally application specific. Authorization rules change with the domain. And you can ask any enterprise who's tried to create a central authorization service how detailed and ugly that thing gets over time. What's that? It's, I don't like it. I just don't like it. That's me. I'm not trying to be mean. I find that it's kind of like when we first started doing Rails applications and writing applications in Ruby, we stopped going off and downloading other people's web application bootstrappers because it was just easier to write it yourself because you're closer to the domain. I find that authorization is like that when you're writing an application. Other people may easily disagree. Blaine.
Yes. So one of the, I'm Blaine, and I was one of the founders of the OAuth stuff.
And I didn't mean it was bad. I just don't want to.
So the intent with OAuth was exactly as you say. I mean, your authorization scheme is completely up to you. What we did was extract from AuthSub and Flickr Auth and Amazon Web Services Auth and a few other ones, basically the existing best practices of how do I do authorization without giving out my password. And on the mailing list, there were tons of times that people came in and they're like, but I want to be able to specify, read-only access, or this sort of access, or that sort of access. And universally the answer was, no, you decide how to do that, and you decide at the application level. We're just providing a framework to sort of say, was the request okay? Did this person make this request? That's all it was.
Yeah. Okay.
So, and I think it's the simplest way that you can possibly do it. It's kind of complicated, but it's better than what we do right now at Twitter is, hey, give us your, everyone gives all of the API developers their passwords, which is a complete nightmare, and I'm not sure how I sleep at night.
So thank you. So that was the brief OpenID demo. We're going to do the CAS demo, and then we're just going to talk. All right? The CAS demo is the way more fun demo. So first of all, in order to use CAS, you have to have a what? A CAS server. So in this case, I've gem installed Ruby CAS-server. It's actually on 0.5 right now. It's not a 1.0 release, but I'm going to use that one and not the Java one. Now, in order to run a CAS server, you have to have what else? CAS client, sure, but you actually don't need a CAS client to run a server. You can run a server in isolation when nobody ever talks to you. Kind of waste your time, but you can do it. But in order to run it, you have to have a certificate, because all traffic to a central sign-on service has to be protected by SSL. It just has to. These applications do not actually launch in unprotected mode. So you have to have a cert. Who here is using anything other than a Starnix environment? Anybody? Anybody still using Windows in the room? Windows people? Oh, don't be sad. Raise your hand. If you're using Windows, go install the OpenSSL libraries. Everybody else, you have what I'm about to do available to you out of the box. It's just a different path. So on a Mac, I'm going to create a new certificate authority for myself. All right? System, library, OpenSSL, miscellaneous, ca.pl, new ca. All right? I'm going to create one locally. I need to enter a passphrase that only I know. I'm in the US, I'm in North Carolina, I'm in Durham, I'm at Relevance. I don't have an organizational unit. Relevance is the name again. I'm not going to give you my email address. I'm done. I now have a certificate authority. What does that mean I can do? Issue certificates. Who will trust those certificates? Nobody. Oh, I take that totally back. I'll trust them. And anybody who trusts me and has access directly to my certificate authority, and I've given them the root certificate, would trust them. This is how organizations create chains of trust internally. They create, right? IBM has a certificate authority at the root somewhere, probably a bunch of sub-CAs, and then they issue certificates in and amongst themselves. Everybody trusts those. If you sent one of those certificates over to Red Hat, no trust. You can set up webs of trust, but it's unusual to do that. So I have a certificate authority that allows me to sign certificates. So next thing I want to do is request an actual certificate. So new request. I'm going to be asked for the same sorts of information. Oops, typed it wrong. All right, again, US, NC, Durham, Relevance. This is my SSO cert. Oh no, Relevance again. don't need that. A challenge password, I'll use my name, relevance again. Now I've got a request, and all I need to do is sign it, since I have this thing. My CA already done. All right, give me the password for that. Yes, I'd like to sign the certificate. Yes, I'd like to commit. Done. I have a signed certificate. That wasn't hard, was it? This is the part that freaks most people out, like when they want to start developing with this kind of application. How do I even get started? Where do I go to get a certificate? Do I have to go to Thought or something like that? Right? You all have this stuff available to you unless you're on Windows and you just have to install OpenSSL. All right? You can look at these files are sitting right here in my directory. There's the new cert is the PEM file there, and the new key, that's the private key. Other thing you need to then do with Ruby CAS server is edit the configuration file. All right, this is what the configuration file looks like. First of all, I'm running it locally as WebRick. You can also run it under Mongrel CGI or Fast CGI. I don't run it locally under Mongrel because I don't want to set up Apache and mod proxy balancer and all the reverse lookup stuff that you have to do. So I just run it from WebRick, and I'm fine. You pass it the certificate file and the key file. Just paths to those. You give it a database to use. I've got a local. Right, don't ever do this, by the way. Right, do as I say, not as I do. Don't use root and no password. That's terrible. It's a security class, for crying out loud. And then an authenticator. I'm using the regular old SQL authenticator. This looks for a table called users, a column called username, and a column called password. Note that that password is stored in plain text. Should I ever do this in production? No, right? There's also an Active Directory authenticator you can use. There's an LDAP authenticator, and then custom. All right? If you want to do a custom one, you write your own, you pass in the lib. All right? No big deal. So that's it. I've already got it configured. I'll run it. Sudo Ruby CAS server. It's going to ask me for the passphrase to that private key that I handed it to it before it'll run. So you got to be, don't fire and forget there. You got to remember to type that in. And now I've got WebRick running. All right. We'll go back to ours. I've created 2 demos now, memos and notes. By the way, I just scrapped the old notes demo, and we're starting from scratch here. So if I go into notes, I'll install the Ruby CAS client. Yeah, go for it. With requiring the password there. Yeah, there is a version that allows you to do the initd startup, in which case you've got to have all the key store, and it's a much more complex setup, and you still have to then provide a password, but that's a password to a key store, which gets the key out, so you don't actually provide the password to the key. It's kind of a pain in the butt, but you can do it.
Can't you rip off the encryption on that key?
What's that?
You can rip off the encryption.
You can rip off the encryption on the key too, yeah. That passphrase is optional. You don't have to, but depending on how paranoid you are, as to whether or not you do that. So, when I generated that certificate, I could have asked for, I should just pass the flag in that said, don't give me a passphrase, and it wouldn't have asked for one. So now I've installed the Ruby CAS client there. I'm also going to do scaffold again. Name, string, body, string. All right. Now, let's open that guy up. Application, views, layouts. Slightly different layout this time. Unless request.username.blank. It'll be blank if they're not logged in. Hello. Request.username. Don't need a login link. Do not need login. Instead, I protect the parts of the application that need to be protected. In this case, the notes controller gets a filter, the CAS filter. Okay? And I also need to do something with my routes file. Map.root controller is notes. Now the last thing you need to do is tell your application that you're actually using CAS. All right? And I'll get that up on the screen here. Let's get rid of some of these comments and things. So I require CAS auth, and to make sure I don't screw up my syntax, I'll just go copy the next 2 lines out of here. I tell it where my CAS base URL is. In this case, HTTPS localhost. And lastly, you don't need to do this unless you have a bunch of apps running locally, but you got to tell it what the server name is. And I need to do this for this particular one because I'm going to have a different port for the other application. All right. So this is localhost 3000. All right. Now I'm ready to rock and roll on notes. I'll go back over here and go into memos. Name is string, body is text. Install CAS on this side. And we're going to come back and talk in depth about this CAS one in just a second, because this is the most important thing about this talk. We'll get this guy up and running. Come on. Come on. There we go. Let's go look in here. What else? Map.root. Controllers, memos. Apply the filter to the memos controller. For filter, CAS filter, and in environment.rb. Just copy this stuff. Oops. Not that one. There we go. Go to the bottom. In this case, I want to say that this application is going to be running under port 3001. All right. Did I miss anything? Oh, yeah, my layout. Let's go put that in the other one as well. All right. Now, if everything goes well, script server -p 3001. Notes. Run that one on port 3000. Localhost 3000. Oh, that's just leftover cookie. All right. Now, what you'll notice that I'm immediately presented with a dialog box about a certificate. This is because I've been redirected over to HTTPS port 443 on a different application, which is, by the way, written in camping, right? I'll show you the code. But I don't have the trusted root certificate installed in the browser's root certificate store. So the browser says, hey, I don't understand. You know, do you trust this certificate? And you can examine the certificate. If you are doing this for real, you will have installed the root certificate in the store and not be asked to answer yes to this. But in this case, it's a demo. I'll say yes, and I want to accept the certificate. And you end up on the CAS login page. It turns out I've got a database with some usernames and passwords. Gehtland and Justin. And then I get redirected back to the Notes application, and you can see that it knows who I am. Here's the key. Open up another tab and go to localhost 3001, not 30,001. You're free to go, ooh, that's hot. That is cool. All right. Now, why is that so cool? Well, you notice that it was completely invisible to the user that they even had to authenticate, let alone that they did. All right? Because what happened was, as soon as I hit localhost 3001, I got forwarded over to CAS, and CAS said, oh, I already have a session with you. I'll give you a ticket. Notice the URL I got redirected back to. Oh, there's this ticket appended to it, right? And when that got handed back to the Rails app behind the scenes turned back around and went back to CAS and said, did you issue this ticket? Awesome. Great. You don't have to have special links between your applications so the user, you rewrite the URL so that they click and they know it's coming from one app to another. None of that stuff matters. as long as the applications authenticate against the same store, then as long as this browser session is open, I'm logged into those applications. As soon as I close this browser session, I'm not logged in anymore. Why? Because the session that I have with CAS is an in-memory cookie. As soon as the browser is closed, that session goes away. That's configurable, but that's the default. Okay? Why is this so cool? It has nothing to do with identity. It turns out that one of the biggest problems that I've seen in Rails development shops is the giant overburdened domain explosion inside of a given Rails application. You'll see a group sit down to write an application, and they'll say, okay, we're going to do notes management. And they write their notes management application, and it's very small, and it's concise, and it does one thing, and it does it well. And then, after they've released it, their boss walks in and says, oh, and now we've got to do memo management too. And they say, oh, well, okay, we'll create another application. Oh, no, you can't do that because now they've got to log in over there. We need to use the same, oh, okay. Well, I'll just cram the memo application into the notes application. Right? And now you've got memos and notes in the same code base. The only reason for which is so you can authenticate once. You throw this in here, single sign-on is actually a refactoring aid. Because your applications can stay small and focused, and your user never knows. Right? All you'd have to do is have these things hosted at memos.myapplication.com and notes.myapplication.com. As far as your user is concerned, it's one app. As far as you're concerned, it's different code bases for everything. That is really cool. It's almost free if you use the open source version. How long did that take? I did it live without screwing up, mind you.
So if you want different users to only have access to certain apps, where does that go?
So, now that's back to authorization. So what you get in the CAS world is you get back the username that's associated with the given user. What's that? What was that?
What was the question?
The question was, how do you say this user can't actually access all three of these apps? Oh, that user can only get to 2 of them. The answer is that's an authorization question, and now you have to still have a database somewhere that has usernames and what permissions are associated with that username, but you're not storing any other profile information about that user. You don't have to store their password. You don't have to store nonces for their password or all that other stuff. So you still have to have a table somewhere that says usernames, links to permissions. Yeah. Yes, just about. Okay. Just about. So to recap the demos, right? The OpenID was pretty simple. The actual OpenID code, if you go and look at the server that was, the plugin that I installed, there's only about 12 lines of code that actually got generated and thrown into the application. You literally just have to be able to do Ruby net HTTP or HTTPS over to some box, get back a cookie, store it, be able to pass it on to the next thing. Right? Which is why I have to use it in a web application, because I don't want to write all that stuff up by hand. But there's nothing that says you can't use these types of services outside of the web environment, but you just sort of have to mimic what a browser is doing by capturing back the information that's being asked for. What's also pretty cool about CAS is that the login box that I showed you is totally themable. You just go write your own view, so it looks like your application, so you don't have to worry about that. There is a lot of cryptography going on in here. A lot of cryptography. There's the SSL part. There's the actual, am I done? Give me 1 minute to wrap up. There is the cryptographic token generation. There's all the hashing. We'll talk after I turn off the mic. But as Glenn Vanderberg asked me earlier, he said, oh, the Ruby CAS server, what does that use for its encryption? And I said, oh, I don't know. I'll go look. And so I went and I looked. And it turns out that the answer is it uses the time-worn version of punting. It doesn't. It just uses SSL for everything except that's how it creates tokens. So all of its cryptographic tokens are just that. You can understand why they might not be using a hash algorithm here, but I can't. So there's all kinds of ways they could have done that differently. This is the Ruby version. I would show you the Java version, but it pains me too much. It's way bigger, right? But this is a camping application, just to prove it. So there's your login page. There's your host, and et cetera, et cetera. So it really is camping, and it's really about 40K, and it depends on 2 other gems, and that's it. Question here.
You were configuring CAS server with host names. SSL certificates are actually tied to IP addresses, correct?
Yes.
One of the problems that I'm using
Domain name. Sorry, yeah, domain name, not IPs. Because if your domain moves to a different IP, you need to be able to port your.
They're not actually tied to anything, which was your second dialog box, the second thing that you hit OK on.
Yeah. But again, and you'll never be forced to deal with those dialog boxes if you actually have the roots. If you got that from, VeriSign, if that certificate you're using you got from VeriSign, then nobody will ever be prompted for either of those dialog boxes.
I run into the problem where if I'm using like Apache with name-based virtual hosts, it basically finds that it looks for the certificate based on the IP address, not the host name.
That's right, because in the SSL,
That's the limitation of
you don't have a domain name yet. You still got to get it.
Right.
That's the limitation not of Apache, but of the SSL mechanism, right? That's before HTTP 1.1 specifies the host.
One person at a time, please.
Time out, and I've been told that I have to cut off, but actually the next talk starts at 1, right? So if I just turn off the mic and shout a lot, is that okay? Or do we have to clear out of here?
Just wrap it up in a minute and then take it offline.
Okay, so your question is what happens?
If I'm doing multiple apps with different clients and whatnot, how do I manage that?
Yeah, so that's actually that's actually a question for your IT guy. I wouldn't be able to answer it, but you should be able to deal with it. Thank you, everybody. Oh, and please champion CAS. This project needs your love.